the Plasma Science Infusion Center. We are a research center at the Massachusetts Institute of Technology, and a lot of our outreach comes in the form of public tours. And so we've got everyone from like the US Navy to second graders coming through the lab and viewing this. So I'll talk a little bit about that tour program, but the most of this time is going to be spent on discussion because I want to spend some time with like community co-creation of these ideas for what we're struggling with, and not the moment of misinformation where someone maliciously is like climate change is fake, but where someone very excitedly is like, I know a thing about this, I've been doing my own research, and states something that is objectively wrong. So quick agenda for the day. We'll set the scene. I'll talk a little bit about what our tours look like and what our audience looks like, give an example scenario, and then talk about some of the considerations for how I've tried to figure out what to do in this moment. And then have lots of ample time for discussion questions as we go through. So we offer laboratory tours, and what that looks like for us, there's two options. The more popular of those is the MFE tour, Magnetic Fusion Experiments, and those tours are related to building the like nuclear reactor that we are working with Commonwealth Fusion Systems on, and those are the projects that people tend to be more familiar with. So those are the examples I'm going to use, but we also offer tours of our HEDP, High Energy Density Physics Labs, which is a chance to look at the particle accelerator, talk about the net fusion shot from the National Ignition Facility that our team helped verify. So we do get the same phenomenon with those tours. However, we offer more MFE tours over the course of the year, so those are the ones I'm going to talk about. And a lot of these tours are run by graduate students, and a lot of those graduate students have like 1 to 2 hours of education training per year. They are not professional educators. They are doing this of their own volition. They like sit with me for an intensive in the fall and one in the spring, and that's it. So a lot of the people who are encountering these things are students with their hearts in the right place, but not teachers with 20 years of experience. So when people come on a tour with us, there are a set of steps that they go through, and they all look somewhat similar. Folks may place more or less emphasis based on their own research and experience, but as a general rule, everybody gets information from me to start. So everybody books through me, and they email and they say, hi, we have a group that is a second grade class who would like to come and learn about physics. And when they do so, they get information about what it is we do here. So I will send them the link to our website, any safety considerations for their group, that sort of thing. And all of these groups are 5 to 30 people. That is largely a space and time constraint. So if we have too many people, they just physically can't fit in the space safely. And if we have too few people, it's really hard to justify pulling graduate students away from their work to give a tour to a single person. Once they get here, they start in what we call our history hallway. It's a big panel that I'll have a photo of in a minute with photos from 1937, the origin of the bitter magnet lab, all the way through the evolution of that lab becoming first the PFC, then the PSFC, all the way through to present day and the research we do right now. This is of great interest to a lot of our adult visitors and very little interest to a lot of our very young visitors. But it tends to be a spot where people just sit and listen and aren't sharing a lot of their own experience, which is the opposite of the next step. We have a linear plasma demo where students get to engage with plasma for the first time. And this is where we get a lot of volunteered information of kids saying, oh, I've seen this before, I've heard of this, I looked this up, I know all about this, I've played with magnets. And this is where that starts to come out. After that, they go into the actual lab space. It's called the East Cell here. It's the name of the room. And again, this tends to be a little more retrospective and a little bit less likely to be a spot where folks share any information with us. And so if they do, it will be numerical, and it's a lot easier to correct and just be like, oh, that, you're off by an order of magnitude, or it's 2, not 3. And so that space tends to be easier. And then our final stop is this diorama of what the arc power plant might look like, which is very difficult to navigate with young groups because the arc power plant does not exist yet and isn't going to exist for quite some time. That is research for the future. And so folks will start to share things as if it is present day and as if that is a reactor that like exists in Devens, Massachusetts right now. And we get a lot of information at this point that is just not accurate. So we'll have these conversations, and as with any engagement with young children, we don't want to talk at them for the whole time. And so we will ask them, have you ever seen lightning before? Have you ever seen the aurora? Maybe you've been up north, and start to try and solicit their own experience with these phenomenons and contextualize it within their daily lives. And all of a sudden, they will tell us things like, oh, yes, I've heard of this. It's Chernobyl. And we have to say, oh, no, that's not us. Or they will tell us, yes, I've heard of, lightning. It's made out of fire and it's going to like burn my house down and it's really, really dangerous all of the time. We're like, you're really, really close. We're getting a lot of the right ideas. And then they'll say something like, yep. And if you stand in a car, the tires keep you safe. We're like, oh, so close, not quite. And they're trying to share information and they're trying to participate because they are excited, because they have done research at home or they have taken a class on this or gone to summer camp. All of this information is coming from a place of genuine interest and engagement. And I really, really don't want to shut that piece down. The fact that they have gone on their own to learn more content is really exciting. And there is this moment of tension to say, well, that's so great that you've learned that. But now everyone else in the group has gotten a piece of misinformation they otherwise wouldn't have had. How do I navigate this space? And I do have the caveat here. I mean, for that setting specifically, when people maliciously spread misinformation, that's a different conversation, right? If folks are coming in and saying climate change is not real on our tours, that is a lot easier for me personally as an educator to shut down and say, oh, that's not right. No, you're coming in here trying to make this more of an argument. I have a lot easier time saying, no, that is incorrect. But with children who are genuinely excited, there are a lot of considerations here. So some of the things that I personally am taking into mind as I'm trying to figure this out, one, we are not a classroom. I don't know these kids. I don't have a sense of how secure their STEM identity is. And so it may be that this is the first time they've gotten up the courage to share that kind of information. And me correcting them is going to shatter that sense of self. And it may be that they do this all the time and they're very used to it. And I have no way of knowing that because I've met them for the first time 20 minutes ago. Another piece that is a specific factor for us is that this is MIT, and there's a lot of weight in that name, that being corrected by a scientist at MIT is going to feel different than just one of your friends or a classroom teacher you see every day. And that is going to feel more like a rating of what you are capable of based on a lot of the physics research that talks about being perceived as a physics person by an authority figure. We are a very, very secure authority figure. There are very few people who are going to say the folks at MIT don't know anything about physics. And so being corrected by us is going to feel different for those students. But they've already told the whole group this. So if I don't correct them for a way to, preserve that sense of STEM identity, everyone in the group now believes something that isn't true because it was endorsed by MIT, who was rated as an authority on this subject. And so if I don't correct them, now there's lots more people who can go out and propagate information that simply isn't correct as they're going through their day, because hopefully they're going home and telling their friends and family about this. Hopefully this was an exciting engagement and they're going back home and saying, hey, guess what, Mom, I learned at school today. Also, guess what I learned at MIT. And if the information that comes after that sentence is incorrect, we've got a problem. And the last thing is this sense of needing to feel like a physics person. Again, we are an authority figure and we are perhaps perceived more as an authority figure than just a summer camp instructor who they've met 20 minutes ago. I'm still a stranger they met 20 minutes ago, but I have a logo on that says, hey, you can trust me. On the flip side of all of that, all of those things have a backward side to them. This is not a classroom. If I correct them, they don't lose anything. There's no grade. There's no penalty for being wrong outside of the social penalty for being wrong. And so maybe it is worth it. Maybe there is a little bit of discomfort and that's fine. On the flip side, we're MIT. We have a responsibility to spread correct information because people are going to take us at our word. If this was something that like another random 8-year-old on the playground said at school, perhaps they would fact check it. If I agree with a sentence, it's unlikely kids are going to go home and fact check me. Not impossible, it's definitely happened, but it's a lot less likely to be what they choose to do because we are perceived as that authority. They've already had enough confidence to share with the group, so there is this aspect of, okay, am I so scared I'm going to hurt their sense of STEM identity that they won't want to talk for the rest of the tour, won't want to keep researching this? But I've got a kid who's confident enough to speak up in front of everyone, and so they feel comfortable with this content to some degree. And if I knew these kids better, I would have a better sense of being able to gauge what the social structure is like. Are they just a really loud kid who would share every opinion? Or is that a sign that, they're comfortable enough that I can correct them and it won't be a big deal? And then this sense of needing to feel like a physics person also involves building base physics skills. And being wrong and taking that in stride and continuing research is a really, really important physics skill. The science process skill of taking in input and then changing your experiment is something that they absolutely have to build if they want to continue down this. And the resilience of finding out the thing you thought was going to work doesn't work is also a really, really important part of that process, because if they do go do research, if they come here and do research, that is absolutely going to happen. There's no way every experiment they run is ever going to work. And so that element is helpful if they can withstand the initial pressure of it. And so we find ourselves in this moment of, I have to answer in the span of normal conversation. I can't sit here and ponder this for 20 minutes to figure out exactly what to do because we are in a group setting on a tour in public. But I have to make a snap decision about how do I correct this child without harming their interest in physics? And how do I correct this child without telling everybody else in the group that they shouldn't share because they might be wrong too? And finding a way to balance, it's okay to be wrong, and that fact is definitely wrong, can be really, really challenging in these moments. And it's something that I have found not to be unique to physics. So my background is from museums. I work in a university lab now, but I've worked in a children's museum and a science museum, and we got this all the time in life sciences too. People would say things like, we're descended from monkeys. So close. And the idea is there, and you don't want to dissuade them, but you also don't want other people to walk away from this with this misconception. And so what I hoped for today was to talk about, what do these moments look like in your programs? What do you do? How do you handle that? And have you found ways to structure those conversations so that the student who shared feels like they can continue sharing and is rewarded for having done, this at-home research of whatever nature it is, and nobody walks away quoting things that are factually untrue from you as an authority figure? So I have some discussion questions that we're going to talk through. And it looks like, Allie, are we going to go into breakout rooms? It looks like there's a lot of people here.
Yeah, I think we can. Why don't we we'll split maybe into 3 breakout rooms for 20 or so minutes, and then we'll come back together so that we can kind of share what each room has talked about.
Perfect. So before we split up, I'm curious if folks have one, like process questions. What does this look like? How does that typically manifest or come about? Or two, like initial thoughts they want to share before we break out, and then I'll put up some discussion questions. Okay. We can go